What's up YouTube? This is Navan Gadral, and remember the last decision you made. It could be what you're eating for dinner, or what car you're gonna buy, and etc. But making any type of decision is so hard to do because there's so many things you need to think about. But what if I told you that you don't need to make those decisions on your own anymore, and something else can guide you to make those decisions? That's what the random classifier does. But what exactly is it, and how does it work? In order to understand how the random forest classifier works, we need to understand trees. No, not that type of tree, but this type of tree.
How did I get here? A decision tree is a tool used for generating insights and find possible consequences such as event outcome, resource cost, and utility functions. To help us understand this better, let's imagine we have a set of 6 shapes. 2 of them are squares and 4 of them are triangles, while 2 of the triangles are colored red and the other 2 are colored blue. Now that we have our data set in place, we want to split them amongst the different classes they are in. So how do we do that? To start, we can split the data set between the different colors that they're in. So we can use a question, is it red, to split up our first node. A node is where a data set splits in 2. Whatever meets the criteria goes into the yes category, and whatever doesn't meet the criteria goes into the no category. So in this scenario, both of the squares will go into the yes category, as well as 2 of the triangles. However, the 2 blue triangles will go into the no category. So now in our yes category, we have 2 red squares and 2 red triangles. So now we want to split this up even more. So our next node question could be, is it a square? Now we can split this up even further by having both of the squares go into the yes category and then both of the triangles go into the no category. Now our decision tree is finished. The random forest classifier is simply a bunch of different decision trees that are working together. Each tree in the random forest classifier makes a class prediction, and the class with the most votes becomes the overall model's prediction. The reason why the random forest classifier works really well is because there's a large number of uncorrelated models, which are the trees, that work together as a committee. This committee can outperform any one individual. The reason for this amazing effect is that the trees protect each other from individual errors. Some of the trees might be wrong, but most of the trees will be right. So working together will allow them to move into the correct direction. In order for the random forest classifier to work well, there needs to be an actual signal in the features, so the model doesn't just guess. So we've been mentioning how uncorrelated models are really important, but why is this the case? In order to understand why uncorrelated models are important, let's take an example. Let's imagine we're playing a game where I roll a dice, so where it can either be an odd or even number. If the dice lands on an even number, you get some points. And if the dice lands on an odd number, you lose some points. Now let's imagine you have 3 different games you could potentially play. One, where you have 1 turn and you have to bet 100 points. 10 games, but you have to bet 10 points each game. Or 100 games you play, and you will have to bet 1 point each. So if we played this game, here would be the end results due to probability. In all the games, there's a 50% probability that you will land either an even or odd. In game 1, after your game, you're most likely going to get 0. In game 2, you're also most likely going to get 0. And game 3, still you're most likely going to get 0. So what was the point of all of that if it's all going to end up in 0? Even though we did this probability thing, we've not actually taken something under account. We're only looking at the probability, and probability can be wrong at times. That's why we need to be looking at the distribution of these points. So let's try that out instead. So I played 100 of each game, which I would not recommend because it's very tiring, because rolling a dice is very tiring even though it looks really simple. So after I played game 1 100 times, I won only 10% of the games. After playing game 2 for 100 times, I won 40% of the games. Finally, after playing game 3 100 times, I won 52% of the games. At the start, these games were expected to give us the same percentage of winning. But after we distribute the games, we have a more clear option of which one we should choose. The random forest classifier is similar, where all of these different games we're playing are just going to hide the fact that we lost some games. So at the end, the random forest classifier will give us the best prediction possible. So now we know why uncorrelated models are important. But how does a model actually do it? Decision trees rely a lot on the data that they're trained on. So small changes that are made to it can result in different trees. The random forest classifier uses this for its advantage by creating uncorrelated trees by allowing individual trees to randomly sample from the dataset, which causes different trees. Now let's imagine we're using the dataset above. If we change one triangle to a square, the trees would look a lot different than the original. This method is called bagging. Normally in decision trees, when we split a node, we look at every possible feature that can be split into. Then we pick the feature that will split the dataset the most. In order to keep the trees uncorrelated, however, the random forest classifier will pick a random feature randomly from a set of features. This forces the trees to be different and vary amongst each other. This causes a low correlation to happen between the trees. This method is called feature randomness. Even though the random forest classifier is an amazing tool for decisions, it has some limitations too. The random forest classifier is very slow and inefficient in making real-time predictions on large data sets because of the number of trees that it's using. In order to have a more accurate model, the model will need to go through a lot of trees, and this can take a lot of time to go through. Even though the random forest classifier has these limitations, it is still highly used in real-world applications because of its simplicity. It's currently being used in finance, healthcare, e-commerce, and much more. In finance, it's currently being used to predict if customers are likely to repay their debts on time or use bank services more frequently. In trade, it's being used to predict a stock's future behavior. In healthcare, it's being used to identify the correct combination of components in medicines. It's also being used to analyze a patient's medical history to identify diseases. Finally, in e-commerce, it is currently being used to determine whether a customer will actually like a product and make recommendations. This is only a fraction of what the random forest classifier is being used for, and its applications are growing day by day. Thank you so much for watching this video. And if you enjoyed this video, please make sure to like the video. And if you're new, please consider subscribing to the channel as well, as we do a lot of technology and science videos. If you want to see me make another video of your choice, please comment it down below, as I'm really open to new suggestions. If you want to see a link to my article on random forest classifier, check the description where I have a link to it. Thanks for watching, and see you in the next one.